Z7 minus 0, comma, dot 7 forms a group. Z7 minus 0 modulo dot 7 forms a group. So this is under modulo. I hope you all know modulo. Anyway, while I am doing this problem, I will just tell you what you mean by modulo. Okay, it is given that Z7 minus 0 is under multiplication 7 modulo 7 multiplication modulo 7 forms a group. Consider. So group means we have to satisfy first 4 closure, associative, identity and inverse. First one, consider your G is equals to Z7 minus 0. For a multiplication modulo, we will have 0, 1, 2, 3, 4, 5 and 6. But it is given in our problem except 0. You can write this as 1, 2, 3, 4 modulo 5, modulo 6. So this is said to be a group. Therefore I can say G, now I am going to prove that G dot 7, G under multiplication modulo 7 is a group. We have to prove that. First one, let us find out the Callis table. This type of problem, you have to form a Callis table. How will you form a Callis table? Let us see. This is to form a Callis table. This is in the form of a matrix, like square matrix. Suppose if you have an elements AI and AJ, you have to find out AI star AJ. Therefore, this is given that it is under multiplication, therefore you put dot. If it is addition plus, if it is given in operation, you have to put star. Therefore, we have to put 1, 2, 3, 4, 5 and 6. Similarly, you put 1, 2, 3, 4, 5, 6. So see here. So now just 1 multiplied by 1 is 1. 1 multiplied up to 7, no problem. If it is more than 7, what happens? See. So 1 into 3, 3. 1 into 4, 4. 1 into 5, 5. 1 into 6, 6. 2 into 1, 2. 2 into 2, 4. See, listen. 2 into 3, we also 6. And 2 into 4 will get 8. What is the remainder here? 8 divided by 7 will give you the remainder is 1. Therefore, we will put the remainder is 1. That is called multiplication modulo under 7 here. If it is 2 pi's are 10. So multiple modulo dividing by 7, the remainder is 3. Therefore, we will get 3. This is said to be the modulo. 2 6 are 12. 7 divided by 12, the remainder will give you 5. So same thing we are proceeding here. 3, 3 2's are 6, 3 3's are 9. The remainder of multiplication modulo 7 is said to be 2. And 4 3's are 12. The multiplication modulo of 7 is 5. 3 5's are 15. So the multiplication modulo of 7 for 15, the remainder is 1. And 6 3's are 18 because 7 2's are 14. 18 minus 4 will give you 4. Next 4 into 1 4. 4 2's are 8, the remainder is 1. 4 3's are 12, the remainder is 5. 4 4's are 16, the remainder is 2. 4 5's are 20, the remainder is 6. 4 6's are 24, the remainder is 3. The next one, 5 1's are 5. 5 2's are 10, the remainder is 3. 5 3's are 15, the remainder is 1. 5 4's are 20, the remainder is 6. 5 5's are 25, the remainder is 4. 5 6's are 30, 4 7's are 28, the remainder is 2. Next one, 6 1's are 6, 6 2's are 8, the remainder is 1. 6 3's are 18, the remainder is 4. 6 4's are 24, the remainder is 3. 6 5's are 30, the remainder is 2. And 6 6's are 36, the remainder is, so sorry, 6 1's are 6, 6 2's are 12, the remainder here is 5. So here only it becomes 1. See, on seeing the Callis table, see the row, first row and every row and column, all the elements in G are there. No elements from outside or no other, we are not leaving any elements in the group G. Every element consists in group G will be in the Callis table. From this we can say closure axiom. From the Callis table, from the carriage table, all the elements in G, from the carriage table, all the elements in G are in between in the carriage table. Therefore we can say the closure axiom is true. Therefore we can say the closure axiom is true. Second one, associative axiom. So associative axiom, multiplication modulo 7 is always associative. If you take any two numbers in multiplication, you take 2, 3 and 6. Multiplication modulo is equals to 2 multiplication modulo into 3, 6. So we will get, right, what we will get? 3 6 are 2 3s are what? 5. 5 6 are 30. We will get the multiplication modulo, the remainder is 2. Similarly, we have 3 6 are what? 18. So the multiplication modulo for 18, the remainder is 4. 4 2s are 8. Therefore the remainder is, 3 6 are 18. The remainder is 4. 4 2s are 8. So here we have 2 3s are 6. 6 6 are 36. 36. Therefore the remainder is 1 here. Similarly, the remainder is 1. The left hand side equal right hand side. Therefore it holds associative. Otherwise, no need to explain this. If you want, you can explain. Always remember that multiplication modulo 7 is always associative. See, let us consider any one of the three values and put the associative property. Next one, existence of identity element. So since this is a multiplication, it is given that if the G equals to 1, 2, 3, 4, 5, 6, modulus under multiplication. Therefore, since it is a multiplication, I can always say 1 is the identity element. From the carriage table, 1 modulo 1 is the identity element. Modulo 1 is the identity element. This is called your identity axiom. Okay, because if you multiply by 1, we will get the same number. 1 is multiplied by 2, 2. 3 is multiplied by 1, 3. 4 is multiplied by 1, 4. 5 is multiplied by 5, 6. If you multiply 1 into 5, we will get 5. Therefore, it is an identity element. Then inverse axiom. So therefore, identity axiom is true. So inverse axiom. So now we have to find out the inverse for each element. Here, what is the inverse element? A star A inverse equals to E. Suppose if you take the inverse for 1, 1 into 1 will give you 1. Therefore, inverse of modulo 1 is 1. Then inverse of modulo 2. So what is the inverse of modulo 2? Where 1 comes, that is 4. 2 4s are will give you 1. Therefore, the inverse of modulo 2 is 4. Next one, inverse of modulo 3. Next one, inverse of modulo 4. Inverse of modulo 5 and inverse of modulo 6 is, what is inverse of modulo 3 will give you 5. And inverse of modulo 4, where 1 identity element is 2. And inverse of modulo 5 is 3. And inverse of modulo 6 is 6. Therefore, this are the inverse. Every element is having inverse element. So therefore, inverse axiom is also true. Therefore, inverse axiom is also true. Hence, we can say we are satisfied all the 4 axioms. Therefore, I can say G is a group under multiplication modulo 7. Under multiplication modulo 7. Okay, with this we are finishing all the 10 marks. So almost every 10 marks should be in the same concept. 3 from your groups. We are forming a groups under matrix multiplication. 1 from the composite functions. Another one, it is given that A star B equals to A plus B plus AB, and one more matrix multiplication. Now we have proved that under multiplication modulo forms a group. The G forms a group under multiplication form. These are the 4 different problems which comes under for your 10 marks. Please go through all the 10 marks in your discrete mathematics. I am sure you will be getting 10 marks from that. It's very easy. Don't think that this always, you may think that the discrete mathematics is the toughest subject, toughest chapter. Don't think that. Once if you are involved in discrete mathematics, that is one of the easiest chapter among all the chapter, among all the units. Okay. Now we will go on to discuss some of the very few important 6 marks questions. Okay.